And from this equation, we know that we have the point x 30. So we can use the formula y equals a cosh of x over a minus a. And this minus a, we can plug in our value for y, so 30 equals a cosh of x over a minus a. And when we simplify it down, we get 30 minus a divided by a is equal to cosh of x over a. And we also know the arc length formula for a catenary, so we can use that as well. That's going to be a sinh of x over a, and that's going to be equal to 40 over a. And we can use our knowledge of hyperbolic trig. You can use the identity cosh squared of x minus the sinh squared of x is equal to 1. And since we have both here, sorry, I made a mistake here. Since we have this equation and we have both of them set to some value, we know that we can just plug it in. 30 minus a over a squared minus 40 over a squared, and that's going to give you 1. So if we expand that out, we're going to get 30 squared minus 60a minus a squared, or plus a squared, sorry, and a squared here minus 1600 over a squared, and that's going to give you 1. And if we do 30 squared minus 60a plus a squared over a squared is equal to, minus 1600. You can see that we can just subtract. We have common denominator, so we can just subtract the 1600 from there. So that's going to be 900, and we know that 900 minus 1600 is going to give you 500, I believe. Oh, never mind. I can't even do math, but it's 700. 700 minus 60a plus a squared all over a squared is equal to 1. And from here we can just multiply it by a squared on both sides, so we get 700 minus 60a plus a squared is equal to a squared, and we have the a squareds cancel, so we have 700 equals 60a. So a is equal to 700 over 60, which can be simplified down to 70 by 6, and I think that can be further simplified into 35 over 3. So we've solved for what value we're going to set this to. So now we can finally start solving for x, the main value we're looking for, the distance here. So we can plug a into our equation of 35 over 3 sine of since of x, well, over 35 over 3 is equal to 40. So we have that, well, that's going to go to the other side, so we're going to have since of x, which is going to be 3 over 35, equal to 40 times 3 over 35. That's going to give you 24 over 7. And now we have to take the arc sinh of this function so that we can get 3x pen is acting weird. 3x over 35 is equal to the arcsinch of 24 over 7. And to solve for the inverse arcsinch of this value, we have to do 3x over 35 is equal to the ln of 24 over 7 plus the square root of 24 over 7 squared plus 1. Then we get that x is equal to 35 over 3 ln of this number here. That's just 34 over 7 squared plus 1. And we plug this into the calculator. We get 7 plus the square root of 24 over 7 quantity squared plus 1. Close this. And we get that x is equal to 22.70 meters. And since we only solve for half the catenary, we have to multiply our value by 2. So 2x is just going to be multiplying that by 2. And we get that the length between, or the distance between the poles is approximately 45.4 meters. And there you have it. That's how you solve a hanging cable problem.